Hi guys, so today we're going to be adding and subtracting matrices. So the first thing I want to bring to your attention here is that matrix A is a 2 by 2 matrix, meaning it has 2 rows. So rows are stated first, and it has 2 columns. So columns are vertical. So this is a 2 by 2 matrix. And if you look at matrix B, it also has 2 rows, which go horizontally, and then 2 columns, which go vertically. So this is important to keep in mind because you can only add matrices and subtract matrices that have the same number of rows and columns. So since we're starting off with A and B and we have both of them as a 2 by 2 matrix, we can proceed to add them. So when we're adding matrix A and B, we're just taking the first number in the first row, first column, and adding it to the number here in the first row, first column. So that would be -5 plus -3. If I take the number in the second row, first column, which is 7, sorry, I know I kind of covered that, I add it to -4. So you're just adding the numbers that are in the same place in the two matrices. So for 2.7, I would add that to -3.9. And then finally for -3, I would add that to 2. So close up the matrix, and from here, my answer should also be a 2 by 2 matrix, so same as what I started with. So I have -5 plus -3. The signs match, so I add, and I take the sign of the bigger number. For 7 plus -4, the signs don't match, so I subtract, take the sign of the bigger number 7, and it's positive. For 2.7 plus -3.9, signs don't match, so I'm going to subtract, and then I'll take the sign of the bigger number, which is -3.9. So this would be -1.2, and finally -3 plus 2. Signs don't match, subtract, and then I'll take the sign of the bigger number. So this is my answer for A plus B. If I'm going to subtract the two matrices, which is what number 2 asks, A minus B, make sure that you see the order because subtraction, the order does matter. So we're going to take the values in matrix A first and then subtract them from the values in matrix B, which since we did the same order adding, I would just take these same values and instead of adding them, I'm going to subtract them. So for instance, in the second row, first column, instead of 7 plus -4, it'll say 7 minus -4. Instead of 2.7 plus -3.9, it'll say minus -3.9. So watch the double negatives when you're subtracting, and then finally you have -3 minus 2. So from here, if I change the minus and the negative to plus, I actually have -5 plus 3. Signs don't match, so I'm going to subtract, take the sign of the bigger number. And then 7 minus -4, that's a plus, which would give me 7 plus 4, and that's 11. Same thing here, the two negatives, I'm going to add the 2. So 2.7 plus 3.9 would give me 6.6. And then finally, -3 minus 2, the signs do match. So I add, and I take the sign of the bigger number, which is a negative. So this is my answer for A plus B, and the answer for A minus B. All right, and then from here, we're going to start multiplying. Multiplying, it takes a different bit of a step because the matrix rows and columns don't have to match. So if you look at this next problem I've set up, notice that this is a one row. So this is one row, and then it has 1, 2, 3. It has 3 columns. This is a 1 by 3. And if I look at matrix B, this has 1, 2, 3 rows, and it has one column. Let me change the color on that one. So it has one column. So why does this matter? When I am multiplying, what this does is, if I know the number of rows and columns, look at the first number and the last number. First number of the first matrix, last number of the last matrix that I'm multiplying, and that's the matrix I should have as my answer, meaning when I'm done multiplying, I should only have a 1 by 1 matrix. So there's only going to be one row, one column when I'm done. So in this case, how would I multiply this matrices A times B? To find the product, I would take each number in the first row and multiply it by each number in the first column and add them up. So I'm just going to show you from here. So I would take the first number in the first row, -3, and multiply it by the first number in the first column. So I would take -3 times the -1. Plus, I would take the second number in the first row and multiply it by the second number in the first column, which is -4 times 4. Plus, I would take the third number in the first row and multiply it by the third number in the first column. So I would take 5 times 5. And if there were more rows and columns, I would still do it the same way. I would multiply everything in the second row by all the numbers in the second column and add them up. Third row, multiply by the third column. So since there's only one row and one column, that's all I'm going to do is multiply each number in the first row by each number in the first column. So from here, cleaning it up, this would give me -3 times -1, which is +3. Plus, I have 4 times -4, which would give me -16. And then plus 5 times 5, which is 25. Since it's just adding and subtracting from here, PEMDAS says you can just go from left to right. So I have 3 plus -16, which is -13. And -13 plus 25 would give me 12. So that's my answer. And notice that my answer does only have one row, one column. One row, one column. So when you're multiplying, you can always take the first row in the first matrix and the number of columns in the second matrix, and that'll give you the type of matrix you should end up with in the end. All right, I hope this helps.